2-to-1 properties of numbers?
Mm-hmm.
That's kind of hard to read, though.
All right, so 2-1, properties of numbers. Our objective today is to identify properties. The first property we have is, can you say that, Cruz?
Commutative?
Very close. It's commutative property.
Oh.
And there's two types. There's commutative property of addition and of multiplication. Very good.
What is that text?
Oh, that's a mistake. I should take that out. Thank you for noticing and making me look stupid.
You're not stupid.
Okay. All right, so for commutative property, if you have A plus B plus C, that's equal to B plus C plus A. Now, that sounds complicated, but what that means is if you have 7 plus 9 plus 13, that's the same as 7 plus 13 plus 9.
Order doesn't matter.
So,
just like multiplication.
Yeah.
But in subtraction, order does matter.
Very good. You're absolutely right. So, if you're looking
in subtraction and division, I meant.
All right. So if you have 7 plus 9 plus 13, 7 plus 9 is 16 plus 13. It's not real hard, but it might be a little bit difficult. But if you do 7 plus 13, that's 20. That's a little easy.
29.
Mm-hmm.
And because you add on the 9.
Very good.
So
now for multiplication, it's the same thing. A times B is the same as B times A.
Order doesn't matter.
Order doesn't matter. So if we do 4 times 9 times 5, 4 times 9 most people can do, that's 36. But when you try to do 36 times 5, that gets a little bit tough. Now, but if we switch it around and we go 4 times 5 is 20, a lot of people can do 20 times 9. Do you know what 9 times 2 is?
18.
And then we would just add a 0, so it would be 180.
Yep.
So commutative property, I think of that as kind of like our moving property. Things can move around, but the values doesn't change.
Yep.
Our second hint is
order doesn't matter.
The order changes. So that's how you can tell if it's commutative property. Next, we have associative property of addition or multiplication. So associative property means that if you have parentheses, those two things get done first. So if I have the quantity A plus B added to C, that's equal to A plus the quantity B plus C. Now, notice we just moved the parentheses. So 6 plus 4, the quantity 6 plus 4 added to 5 is the same as 6 plus 4 plus 5. And the same deal with in the multiplication part. The quantity A times B multiplied by C is equal to A times the quantity B times C. In other words, the quantity 6 times 4 multiplied by 5 is the same as 6 times the quantity 4 times 5. Our hint here is that I think of this as the hanging out property. Those parentheses, those little curvy things, those are like the clubhouse. And sometimes the two people are hanging out in the clubhouse, and then it can change around. So you can have your best friends, okay? I think of it as kind of your best friends. A and B are best friends, and then it switches, and B and C are best friends. Yeah, kind of funny.
Are those your best friends?
No, those are not my best friends. That's I forget who that's. Nicole Richie and Paris Hilton. That's it. So no, don't know them. Okay, and the other hint that's kind of important is that the order does not change. If you look at both of them, it's A, B, C on the left, A, B, C on the right. So order doesn't change for associative property. Next, we have the identity. Oh, sorry, go ahead. Okay, of addition and of multiplication.
When are we going to get to subtraction and division?
We're not going to do that today.
Okay.
So we have A plus 0 is equal to A. That's pretty easy. In other words, 9 plus 0 is equal to 9. 0 plus 10 is equal to 10.
Yeah, just adding on.
And then
zero.
If you add 0 to anything, it doesn't change, does it?
Yep.
Now, multiplication, what can you multiply by and the number doesn't change? Do you know?
No.
So 9 times what would equal 9?
I don't know.
Okay. How about A times 1 equals A? Or 6 times 1 equals 6. 1 times 10 equals 10.
I forgot it's 1.
Yeah, it's 1. Now, one thing we want to remember is that
0.
So additive identity, that's the same as the identity property of addition. And multiplicative identity is another way of saying identity property of multiplication. So our hint here is this is kind of the mirror property because it's who you are. And who you are doesn't change when you look into the mirror. So you can think of it, that's who you are. It's almost like a driver's license type of thing. Okay? So you have different driver's licenses. Okay, what's this one?
Inverse.
Inverse property of addition and of multiplication. For every a, then there is an additive inverse negative a, such that a plus negative a equals 0.
I did not know that.
Well, you haven't gotten to that yet. So an example would be 9 plus negative 9 equals 0. So you're just adding the opposite value. For multiplication, it's a little more complicated. For every a, and a cannot equal 0. So a has to be a number other than 0. There is a 1 over a, which is the multiplicative inverse, such that a times 1 over a equals 1. And that sounds complicated, but really all you're doing is you're doing 7 times 1 over 7 equals 1. So if I had a number, say, let's say I did 10.
Just like 7 times 1. No, just sorry.
That's okay. So, Cruz, though, if my number was 10, what would my fraction be? If it was 7 and then the fraction was 1 over 7, if my number's now 10, what would my fraction be?
I don't know.
1 over 10.
Oh, silly me.
That's okay. Here's some other properties. Oh, I know, it's summertime. Review of additional properties. So here's the distributive
property.
And basically that says that A times the quantity B plus C is equal to AB times AC. And I'll talk about that later. Maybe you can help me with that next lesson. It also works for subtraction problems. So A times the quantity B minus C is equal to AB minus AC.
You told me that you weren't going to do subtraction and division in this.
Oh, I'm sorry, I lied. Forgive me. I was mistaken. I forgot. I didn't lie. I forgot. Then we have multiplicative property of 0.
Ooh.
For every real number, n times 0 equals 0. So basically all that means is whenever you multiply by 0, what do you get?
0.
0.
0.
0. Next we have the multiplicative property of negative 1. For every real number, n times negative 1 equals negative n. So for example, negative 9 times negative 1 equals 9. So basically what it's saying there is when you multiply by a negative, you get the opposite, or when you multiply by a negative 1, you get the opposite of that number.
But then why did that say just 9?
Well, because the opposite of negative 9 is positive 9.
Oh.
Now we want to choose what property would this be an example of. So one of the things I look for when I'm trying to decide what property it is, and we're going to choose from these 5 properties: identity, commutative, associative, distributive, or inverse. So I'm looking to see, does the order change here? So it's 4A, 5B, 6C on the left.
It does not change.
Okay, so the order doesn't change. What changes is the parentheses, who they're hanging out with. Do you remember what the hanging out property was? No, that's okay. It's
inverse?
Not inverse.
Associative?
It is associative. Good job. So remember, associative property is the hanging out, best friends property. You remember that?
Yeah.
Okay. Number 2, 16 plus 0 equals 16. So when you add 0, what property is that when you're adding 0?
Commutative?
Nope, that means things move.
Oh, so identity.
Good job. Identity property. Remember, think ID. It's who you are. So think driver's license. Okay?
That's a funny one.
Yeah. Do you know who that kind of looks like?
No.
Kind of looks like your grandpa. Grandpa Gore? No? Okay. Number 3. 2 over 3 times 3 over 2. That is inverse property of multiplication.
inverse, which is the last one, so you should remember that.
Okay. Remember, you're multiplying by a number over itself. Inverse is when you flip things over.
Whee!
That's a picture of you when you were snowboarding. Do you remember doing that flip?
No, I did not do a flip.
No, you didn't do a flip.
But it would be cool if I did.
Yeah, it would be very cool if you did. Okay, so we have W times R is equal to R times W. So is the order the same?
No.
Okay, so
It's
that...
commutative.
Very good. Excellent. You got that one all on your own. That's the moving property. Okay, we have 12R times S and then 12 times RS. Got a guess as to what this one would be?
Distributive?
Nope, but it's good because distributive does have parentheses. But with a distributive, there's going to be a plus or minus inside of it. This one is associative property.
To one
Because
just
the order,
right above it.
Yeah, the order doesn't change. And that's the end.
Bye.
Okay. I'll show you the lesson if you need to do the lesson. If you're in the flip class, you don't do the lesson. I'm also going to try to put a video if it'll fit in. We'll see if it fits. Okay, you're all done.
Okay.
Behold, the calculator. But where did it come from? Meet William Seward Burroughs, born in New York in 1857. William Seward Burroughs, not to be confused with his grandson, the author William S. Burroughs, spent his childhood in New York. After school, he began working as a bank clerk until the harsh winters wore on his health and sent him packing to warmer climates. Even after moving to St. Louis, William remembered his time at the bank, especially those long, monotonous hours spent crunching numbers and correcting mistakes. There had to be a faster way to perform basic calculations, a way to automate arithmetic. In 1888, it was official. He invented the calculator. This device looked more like a cash register than modern rectangular scientific calculators. While earlier patents tackled the same idea, William's design was the first practical example of an adding and listing machine. It wasn't perfect. In fact, users had to be careful with the original lever-operated machine. If they didn't pull the lever correctly, the machine would show different sums for the same calculation. Luckily for us, William stuck with it and improved the design. In 1886, he helped form the American Arithmometer Company. By 1926, they changed their name to the Burroughs Adding Machine Company and made around 1 million devices. So, how genius is this inventor? On the American Dream scale, he gets a 5. William Burroughs was able to take a good idea and successfully build a company based on his inventions. On the benefit to humanity scale, he gets a 4. Since the invention of the abacus, human beings have searched for quicker ways to perform calculations. Burroughs' machine formed the basis for the calculators we use today. On the ripple effect scale, he gets a 5. Calculators are not a niche invention. People and companies throughout the world use these handy machines to save thousands of number crunching hours each year.